Greetings, this is Artie from Artifact Electronics. In this episode we'll have a look at the Nintendo Virtua Boy video game console from 1995. This wasn't a very successful product. It was only on the market for about a year, and it sold less than 800,000 copies. And that is significant as far as Nintendo is concerned, because they were selling their products in the tens, if not hundreds of millions. And this was in a new direction. This was actually this was a VR goggle, except the difference was you didn't strap it onto your head, but rather you strapped yourself into it, i.e. You placed your head strategically in here, into the hood, and then you played the game while holding the controller in your hand. 3D gaming nowadays, where most games are in 3D, are achieved by basically creating an offline image in 3 dimensions and then flattening it or projecting it onto a screen. And with head movement and eye movement, it causes your brain to be fooled into thinking you're looking at an actual 3D image with depth in it. And you'd agree it works rather well. Now, the way this thing worked was it used 2 stereographic images, and what that means is there were basically 2 images, identical images that were slightly offset from each other in the left and the right eye. And I don't know if you remember the Viewmasters, but the little machines you looked into, and then you put the disc in there with pictures on them, and the pictures looked 3D, and that was how they were achieved. The pictures were just slightly offset from left to right eye, and it gave an illusion of depth. And that's pretty much what the same principle that this works on. It's got the 2 eyepieces, and the eyepieces basically show a similar, if not identical, image, except that they're slightly offset. There's a slightly offset copy in one of the eyes, and that gives you the illusion of depth. And it does work when you look at it. It looks like you're looking into 3D world. Now, why did this fail? And especially with something that Nintendo came out with, and I think when it came out in '95, technology was still too expensive to make a good one. This one is monochrome with red on white, red on black. And I think they should have at least gone to RGB to be able to put some color into it. It would have made a big difference. It uses LEDs for the display, and but at that time blue and green LEDs were too expensive, so they stayed with red. And the way it works is basically there's a column of red LEDs on each side, one here and one here. And that column shines onto a mirror that's offset approximately, or base offset 45 degrees in here, so that the image, the column that shows up on this LED, comes out in your eyepiece, in your display. Let's call these display 1 and display 2. How did you achieve a whole screen with this? Well, the mirrors are spinning rapidly. They're on stepper motors. So essentially the image is built by putting up a column, leaving it up for a certain amount of time, then turning off the LED column, stepping the mirror a little, rotating the mirror a little bit, and coming up with the data, putting the data for the second column onto the LED strip, and so on and so forth. So basically you have 2 rapidly rotating mirrors in here, and a column that changes, and the whole thing is of course synced up. And that's how they build an entire rectangular image. And again, they build 2 images, but they slightly offset them from one display to the next. And when you're sitting just right, with the hood blocking out all external light, you get to see a 3D image. Well, let's see if I can show you some of the images. The difficulty in showing these images probably had a lot to do with Nintendo not being able to create any effective advertising, because it's It's very hard to film this, and of course totally impossible to show the depth effect on it. So anyway, here we go. Fortunately, what usually goes wrong is the displays basically have garbage in them. Extra garbage. I mean, it shows the actual image, but for instance here it's a startup screen with some text on it. And let's see if we can go closer, if we can actually get this thing to focus. And so we can kind of see the image here. The flicker you're seeing is not as intense off camera. The camera intensifies it quite a bit. But remember, these the mirrors are continuously spinning, and that's what the camera's picking up. So again though, and you're only seeing part of the image, like the center of the image. There's stuff cut off left, right, top and bottom, and that's because of the way the lenses are set up. But let's see if we can look at the other one, and yes we can. And essentially that has the same text on it, which you can kind of see coming through there. But there's extra garbage on. There's certain horizontal lines that are stuck on, and that is the main problem here. The left display also did it once in a while, but you know, it's coming up cleanly now, but the right display is obviously stuck with the garbage. So that's what it's supposed to look like, and if we step a little bit forward, there's the game logo, and there's the game logo on the other side. As you can see, the graphics are happening, but there's just some lines that are continuously stuck on. And finally, to start going into the game, this is Mario Tennis, by the way. He'll hit you in the head with the ball. So this is what it looks like on the left. This is what it looks like on the right. Again, I said it was a common problem. I've done some research on it and I have a pretty good idea what's going on here. So let's take this thing apart, see some of the innards, and see if we can fix the stuck lines. A few more details about this. The sound actually works really well because it's got two speakers here and here, and because it's forcing you into stationary head position with these, with the goggle position or the hood here, you're getting some pretty good stereo sound along with your stereographic image. Then it's got two adjustments on top. One of them is focus, which these are mechanical adjustments actually. There's no pots in there, but the mirrors are being moved around. And then there's another, a rotary control labeled IPD. And I had to look up what that meant because I couldn't figure out what it was doing while looking at an image. But IPD stands for inner pupillary distance. So you adjust it for the distance between your eyes by rotating it. It's also mechanical and doesn't turn very smoothly. But when we open it up, we can probably see what those knobs do. Opening this thing up is not a big deal. I've got to remove the cartridge. And there's a total of 12 screws holding the whole thing together from the bottom. Now they're using security screws. So what you need to do is get a security bit like this. Let's see, does that show up? Kind of. Nowadays you can get these security bits on eBay for a few dollars, but back in 1995 you couldn't go to a store or order them from anywhere. You basically had to have them custom made. And in those days we called them the Japanese gas meter screws, because supposedly those were the kinds of screws used on gas meters, so the common man couldn't mess around with their gas meters. So I've taken out some of the screws. Let me take out the rest and open it up. Okay, I got all the screws out, so first we need to remove the hood. Here's the lenses in there. I don't know if you can see that, but they're scratched up pretty well. I mean, they need to be polished, but it should just come apart now. And it does. So here's a CPU board, and the specs say that it's an NEC V810 32-bit RISC processor running at 20 megahertz with a meg of DRAM, 512 kilobytes of PS RAM, and a 1 kilobyte cache. And the display is an RTI, Reflection Technology Incorporated SLA P4, with a resolution of 384 by 224 and 32 levels of intensity. And I'm going to stop reading back the specs now. But if we look at this, let's take the speaker out. Here's one of the LED columns shining into the unit, and of course here's the other one, and there's a ribbon cable going from the CPU board to these, and the problem lies in the ribbon cable connection to the PCB that contains the LED strip. Let's see if I can get a better view, or give you a better view of that. Seem to have a lot of light here. So the problem is right in the middle of the screen, because what they did is basically you have this flex cable coming down here, but the way the flex cable connects to the PCB is there was adhesive, some sort of adhesive foam on here that they used to just stick this onto this PCB. And the problem with that is that after 20 some years, the adhesive loses strength and the contacts start lifting off the PCB, and that's what's causing stuck lines, because I guess if they're left floating, they come on. Now, there's two ways to fix this. The faster way is, I've seen this, that I've seen done, is basically use a heat gun on this strip over here and basically reheat the adhesive, or the foam, the adhesive foam, and then press down on it once you see that it's warm enough, and then let it cool. And supposedly that will make these contacts properly contact this board again. However, it is probably a temporary solution, because whatever caused the adhesive or the foam to come off, you're going to be able to reconnect them by temporarily melting some of this. And just by melting the material, you're going to create new adhesive properties there that stick it to it. But the real way to do this is to essentially melt off the flex material. And when I say melt off, I should say dissolve the flex material. And I don't know exactly what solvent was recommended for that, but you put that solvent on here and it just eats all the plastic. And what happens, what you have left is the bare metal contacts here. I mean, this whole thing will of course pop off the board, because it's the adhesive that's holding the whole flex flex wires to this board. But then you have to go in and actually solder every one of these strands to this PCB, to the contacts on the PCB. Now, these dimensions are in surface mount land, and not impossible to do if you use lots of flux and lots of patience. You can probably do it. I mean, I've seen pictures of it done. But the people who did it looked kind of frazzled when they were showing the results. I mean, what you get is all of these lines are attached to this board with some solder. So you see all these lines of silver solder over here. But it's a very difficult procedure. And if you solder a surface mount device, at least the pins you're soldering will stay in place because they're attached to whatever chip you're soldering. But in this case, once you dissolve this plastic, these contacts tend to not stay straight because there's really nothing, they're very thin and nothing holds them in place in the proper orientation. I mean, they're still attached up here, but they tend to bend left, right, up, down, and you end up having one hell of a time keeping them straight while soldering them on extremely fine-pitched circuit traces over here. So the decision I made is to try to use the soldering gun, the heat gun approach, for the simple reason that I'm not going to be playing this 8 hours a day. It's part of my collection. Probably play it for a few hours once I get it fixed, and then it's going to go into storage and come out once in a while. So I believe that the heat gun approach will probably fix it well enough for me to have a working unit for years to come. But let's look at the cause of this, or what people guess the cause is for those coming loose. Remember, we had the inner pupillary distance adjustment in here, and what that does, where did you go? It's the little dial you turn. Now, if you look at the flex cable while I turn the dial, you'll see that that whole assembly is moving in and out, and it's moving the flex cable. And the pressure it puts on the connection of the flex cable on the PCB is probably what eventually loosens the adhesive and causes intermittent, if not totally open, connections there. So, of course, one solution is to adjust the interpupillary distance for your eyes and then put a big glob of something on there so you can never touch it again. But that's not a realistic solution, obviously, but that seems to be the problem because that's the only thing that stresses this connection over here. But let's try the heat gun approach. But before that, let's have a look at the little mirrors I was talking about earlier. I disconnected the display connectors, and they just simply pulled out in order for me to be able to get the PCB out of the way. And I have a cartridge in here now, and you can see the back of one of the mirrors here for display 2, or the right eye, and over here you can see the stepper motor. And notice, of course, how the mirror is at a standstill, but if we turn on the game, you can see it start rotating rapidly. I mean, it's spinning back and forth, achieving all the different angles in order to project, in order to build a rectangular image out of the column of LEDs that are shining onto this. And of course the other side is identical to it. So back to the problem, of course, that we need to fix. What we need to do is take out the PCBs with the connector and then carefully heat gun the connections. So here's the culprit. Here is the LED part, and it looks like I was wrong. There's actually 3 LED strips here, 2 large ones on the outside and a smaller one in the middle. There's no chance in hell we're going to see how exactly that works, but these are the ones that light up and probably alternate between left and right and synchronize that with the angle of rotation on the mirror. And here is where we need to apply the heat gun to. We're going to have to cover both sides with aluminum paper so we don't heat things up. I mean, one of the reasons that they didn't solder this, I mean, my guess is that this was a manufacturing convenience to just stick these on, but they might have also not wanted to heat up the LED elements too much. I really don't know. And that's another reason why I am happy with the decision to just use the heat gun for now, because it's not nearly going to impart as much heat on this as when having a soldering iron and trying to align all of these contacts over here and soldering them to the board. So the idea is to heat gun this junction just to the point where you can start seeing the plastic start to melt on top. At that point you pull it off and you press down on it, so while it cools down again, hopefully it will stick to the board. So here we go. All right. Well, that's it. Let's put it back in and see if that made any difference. I put it all back together again, and it worked. Of course, I had a hell of a time trying to get the image to appear on video again. I couldn't even get it to the point where I had it last time, but we are looking at display 2, the right side, and moving it over. Here is display number 1, the left side. All the horizontal lines are gone, and looks like it got fixed. So now it's only a matter of seeing how long will this fix last. So I'm going to leave this nice and handy so I can try this for a few days in a row and see how well the repair holds. So I forgot to mention that while it was open, I also heat gunned the other side LED flex cable while it was open, because that one was, I did see it act up. It wouldn't do it today, but it did act up, so I gave both of them the treatment, and as you saw in the previous scene, they are both fixed now. So to sum it up, I guess it was a good deal after all. And of course the head unit and the stand came with it. A lot of times when you buy these, they're missing the stands or the controller or whatever, but this was complete, more than complete actually, because normally they come with a battery box that slides into the back of the controller, and the controller actually powers the whole unit. But this one came with the wall adapter. Well, this is the adapter for the wall adapter that slides into the controller and then plugs into the wall over there. It came with 2 games, a Mario's Tennis, which you saw in the beginning, and what I spent like 15 minutes on, it also came with Galactic Pinball, and that one's actually fun. It's really well done, and I saw myself forced to play that game for 15-20 minutes to thoroughly test this Virtual Boy, and it passed with flying colors. And for the last bonus, I'm going to have to switch camera views here, so hang on. And here's the best bonus, and I didn't even know this when I was buying it, because just as I was about to leave the store, the salesman said, "Oh, I forgot something." And he comes out with this plastic box. Turns out that this Virtual Boy was part of a fleet of consoles that were rented out by Blockbuster Video. I guess they had 6,000 of these that Nintendo tried to get to the masses by making a deal with Blockbuster and renting them out. And of course, in order to rent this out with all the little bits and pieces, they needed a proper way of transporting it. So it came with its own case, and everything fits nicely and neatly inside. So that was a great bonus after I was happy to have bought this already. And let's see if the repair will last. So I hope you had a good time, and if you buy Virtual Boy, go ahead. 95% of the problems are usually the displays on these, and just use the little heat gun method I showed you. Now, when I did the second one, I thought about that procedure again, and I figured one of the things I would do is leave out the last part where I run a pen over it to kind of flatten the connectors to the PCB. And the reason for that is if the plastic's still hot and you slip, you may move one of the connectors and inadvertently short it to one of its neighbors. So when I did the second one, I didn't even run the pen over afterwards. And second of all, do it in steps. What I would do is basically do 15 to 20 seconds of heat gunning from the time you turn on the heat gun. So you preheat the board, of course, but start up close. Install the LED back in the system and see if it fixed it. If it didn't, repeat the procedure with 15 seconds this time. And just keep doing it a couple of times until those contacts stick. And you should have no problems getting your Virtual Boy up and running. So please don't forget the like button. Don't forget to subscribe. And I'm looking forward to seeing you in the next installment.